This is Rational Graphs Part 2. Here's all the information we know we need to find. Here's our original function. Let's take a look at symmetry on the next page. To check y-axis symmetry, we want to see if f of x is the same as f of negative x. So we're going to plug in negative x every place we see an x, work this out, and this is what we get. Are these two things the same? If they are the same, then this function will have y-axis symmetry. These are not the same, and you may say, wait a minute, how do I know they're not? Well, take a look at this. This is the opposite sign. This 2x has the opposite sign, which means negative 1 should have the opposite sign if these really were the same, and they're not. So there is no y-axis symmetry. Negative f of x, I put a negative in front of the fraction. The negative can be distributed to the top or the bottom. I send it to the top. To check origin symmetry, I need to check to see if these two things are the same. And the same thing, this is negative 2x minus 1. This is negative 2x plus 1. They are not the same. So there is no symmetry at all in this. To find the y-intercept, we're going to evaluate f of 0, which means plug 0 in for x up here. Work this out, and you're going to get negative 1 over 0, which is undefined. You can't divide by 0. If this is an undefined expression, that means there is no y-intercept. X-intercept, set the numerator equal to 0, and solve. When I solve this, I get x equals 1/2. Vertical asymptote, set the denominator equal to 0 and solve. Well, there's nothing to solve. Once I put this equal to 0, that's it. X equals 0 is my vertical asymptote. Horizontal asymptote, you want to take a look at your degree. This is the same degree, top and bottom. This has an expression of 1 there. So we're going to end up with a horizontal asymptote of 2 because the ratio of the coefficients is 2. Now check to see if it crosses the horizontal asymptote. What we're going to do is set the original function, which is 2x minus 1 over x, equal to our horizontal asymptote, and solve this. Give this a denominator of 1. Cross multiply, we have 2x equals 2x minus 1. If I subtract 2x from both sides, I get this expression, 0 equal to negative 1. That says that this does not cross the horizontal asymptote. So here's all our information put together on one page. There was no symmetry, there was no y-intercept. The x-intercept is 1/2. There's a vertical asymptote at x equals 0, which I have drawn that in the green. There's a horizontal asymptote, y equals 2, that's the yellow. It does not cross the horizontal asymptote. So the only thing I can put on this graph other than my asymptotes is the fact that there is an x-intercept of 1/2. I know it's crossing right there. That is enough to tell me that this most probably does this, and its opposite curve is up here. There's no way the curve could be here. If this curve really goes here, there's no way the other curve could be here because that would mean we didn't even have a function because it wouldn't pass the vertical line test. So this is what we're probably going to get, but we're going to verify it by doing the arithmetic. If we put 1 in here, 2 times 1 is 2, minus 1 is 1, over 1 is the point over 1, up 1. Put 2 in here, 2 times 2 is 4, minus 1 is 3, over denominator of 2. That's 2 comma 3 halves, which is the same as 2 comma 1 and 1/2, over 2 up 1 1/2. So you see our dots coming in line here. So here's this curve running close then to the asymptote down here. Check it out on the other side. Put negative 1 in here. 2 times negative 1 is negative 2. Minus 1 is negative 3. Negative 1 in here for x gives me negative 3 over negative 1, which simplifies into a positive 1. So negative 1 up positive 3, which helps me verify that my curve's going to be here. We can do one more point. 2 times negative 2 is negative 4, minus 1 is negative 5. Put negative 2 right here. I'm looking at negative 5/2, negative 5 over negative 2, which gives me a positive 5/2, which is the same as 2 and 1/2. So to the left, negative 2, up 2 and 1/2, which is about here. There's my points. Bring your curve right on in, and it does not cross the horizontal asymptote as we verified by solving on the other screen. So there is our curve. Next problem. Let's check out all this on the next screen. Symmetry, we want to check f of x compared to f of negative x. F of negative x means put negative x in for each of these x's, which I've done here. Work out the top, stays negative 2. The bottom becomes x squared plus x minus 2. These two are not the same. Clearly, the only difference is a plus here and a minus there. So there is no y-axis symmetry. To do negative f of x, I'm just going to negate the entire fraction. When I send the negative to the top, I get positive 2 over this, and these two things are not the same either. Now, one little thing you could do to verify, you can stop this video, write this down. You could just plug some numbers in for x here and see that you're not getting the same thing. If you plugged in numbers for x here and plugged in the same number for x here and got the same thing, then that would verify that these were the same. They are not. So there is no origin symmetry. There is no y-axis symmetry either. No symmetry at all. Y-intercept, we're going to do f of 0, so I'm plugging 0 in for each of these x's, do the arithmetic, and I'm just going to get 1. So I have a y-intercept at 1. X-intercept, set the numerator equal to 0 and solve. Well, that's kind of silly. Negative 2 equals 0. There's nothing to solve, and that's O, x-intercept. Vertical asymptote, we're going to set the denominator equal to 0 and solve. To solve this quadratic equation, we're going to have to factor it. This is how it factors. Set each piece equal to 0 and solve, and we get x equals 2, x equals negative 1. So we have two vertical asymptotes. Horizontal asymptote, we want to check the degree of the numerator and denominator. Well, the degree in the numerator is 0. The degree in the denominator is 2. Therefore, the numerator degree is less than the denominator degree. So we have the x-axis is our horizontal asymptote. That is the line y equals 0. To check to see if our curve will cross the horizontal asymptote, we're going to set the function equal to this horizontal asymptote and solve. If we set this equal to 0, cross multiply, whatever you want to do, you end up with 0 equals negative 2, which is nonsensical. Therefore, it does not cross the horizontal asymptote. The only way it's going to cross the horizontal asymptote is if you end up with something here like x equals negative 2. That would tell you it crossed. Since we get this with no variable, then we know it doesn't cross the horizontal asymptote. So here's all information. No symmetry, y-intercept of 1, no x-intercept. Vertical asymptotes, 2 of them. I have graphed them here in green at 2 and negative 1. Horizontal asymptote, the x-axis. And it does not cross the horizontal asymptote. Because this is all we have, then we're going to have to do some arithmetic to fill in the gaps here. I do know that this cannot cross like this. If it did cross like that, that means we would have had some x-intercepts, which we do not have. So since this is here, and I know we don't cross this axis, most probably we're going to get some sort of parabola coming through here. But to verify that, we'll do the arithmetic. I've already done the arithmetic here to save a little bit of time. You can stop the video and do the plugging in yourself to verify that these are the right values. But negative 3 will give us negative 1/5, so that's just barely off of the asymptote. Negative 2, we're at negative 1/2, which you can see that we're coming like this. So we're getting this curve over here. It doesn't do all this bouncing around. It really does run closer to the asymptotes. I just have a hard time drawing that. Over here, 1, 1. I'm right there. This does not come like this and go straight across. It's going to do some sort of dip here. To find out how much it dips, I did the arithmetic on 1/2, which is the value between 0 and 1. I get 8/9. So it just barely is below 1, which verifies the parabola idea I told you a couple minutes ago. To find out what happens over here, I did 3 and 4. Over 3, down negative 1/2. Over 4, down negative 1/5. So we've got the same looking curve on this side coming through and hugging the asymptote.